the scientific evidence is stronger than ever. Better and more observations, improved understanding of the climate system response, further development of climate models, all point in the same direction. Human influence on the climate system is clear.
IPCC 第5次评估报告第一工作组主要做的是气候变化的科学。它对这个过去6年以来气候系统各个科学的分支，所以呢，在气候系统的实际观测中证实气候系统正在变暖。
We have looked at all the evidences that tell us how the climate has changed in the past and presently, took that evidence to ask ourselves how we understand the climate system, what the causes of these changes are, and then take that knowledge and climate model simulation to ask ourselves what possible futures are there.
Many of these observed changes are unusual or unprecedented on timescales of decades to millennia. Ice cores contain an abundance of information about climate. Paleoclimate records show a close link between CO2 concentration and temperature. These trends are seen in current observations. Each of the last 3 decades has been warmer than all preceding decades since 1850, and the first decade of the 21st century has been the warmest.
Well, I think in AR5 we've done a much better job of expressing exactly how much different contributions, particular greenhouse gases, have contributed to global warming in the past and how they will contribute in the future. We're able to demonstrate that the CO2 concentration in the atmosphere has increased by 40% since pre-industrial times, mostly as a result of human activities, and that the levels of carbon dioxide in the atmosphere are higher than they've been for the last 800,000 years in Earth history.
The effects of global warming are most evident in some of the coldest places on the planet. Ice sheets and glaciers worldwide are losing mass, permafrost is thawing, and the snow and sea ice cover in the Arctic is decreasing.
We are getting a lot of signals from the cryosphere in terms of warming. The most visible signs of warming can be found in the Arctic.
Arctic sea ice extension has shown a downward trend since 1980. A downward trend is also observed at the Greenland ice sheet.
The amount of mass that's lost in Greenland is about 6 times as much as what was observed 10 years ago.
The observed changes in the cryosphere have serious implications. With less snow and ice, more of the sun's energy is absorbed by the ocean and land surface. This is one of the powerful climate change feedbacks that influences the whole climate system. Based on multiple lines of independent evidence, it's now virtually certain that the ocean is warming.
The warming of the ocean will continue even if we stop the atmospheric CO2 concentrations to increase, because the time scale of the ocean circulation, which connects the surface to the deep ocean, is very large in the sort of hundreds and thousands of years.
There are 4 major contributors to sea level rise: ocean heat uptake, melting of glaciers, reduction of ice sheets, and changes in water storage on land. Improved scientific understanding has made scientists able to make a consistent sea level rise budget.
Over the 20th century as a whole, The dominant contributions are ocean thermal expansion and the contribution from the loss of mass from glaciers. Sea level has risen by about 19 centimetres by 1900 to 2010, and it's continuing to rise. We will have to adapt to sea level rise.
Our understanding of the climate system relies on combining observations and studies from many different scientific disciplines. With the help of supercomputers, this knowledge can provide climate projections for the future.
Climate models play an absolutely crucial role in this assessment report. They are the only tools that allow us to say something quantitative about the future. Historically, climate prediction has started with predicting weather, the atmosphere, then we included the ocean, and now we're at the point where we include every component in the Earth system, including the carbon cycle and the chemistry. So that allows us to have a really comprehensive view of all the relevant processes for future climate change.
Climate change projections require information about future emissions or concentrations of greenhouse gases, aerosols, and other anthropogenic drivers. A new set of scenarios was used to project the cumulative CO2 emissions in the future.
Model simulations employing the RCP scenarios tell us we have a choice. We have a choice to live in a world in which climate change is limited to less than 2 degrees Celsius, or in a world that is warmer than 4 degrees Celsius.
Climate models employing the RCP scenarios provide policy-relevant information on a regional level. For the first time, Working Group 1 has developed an atlas of global and regional climate projections, which allows decision-makers to see how climate might change in their regions. This can facilitate more informed decisions on adaptation strategies.
We have 3 key messages. A warming in the climate system is unequivocal. That is based on the observations and the multiple lines of independent evidence. The second message is human influence on the climate system is clear. This is resulting from the combination of model simulations with the observed climate change. The third message is that continued greenhouse gas emissions cause further climate change and constitute a multi-century commitment in the future. Therefore, we conclude limiting climate change requires substantial and sustained reductions in greenhouse gas emissions.